So they said graph this function as a solid curve, which it's done correctly in all of our multiple choice options. That's the graph of e to the x, and that's the general structure of a basic exponential function. It just starts growing out of control as time goes on. Okay, what are we supposed to do? Graph the inverse, right? That's shorthand notation for the inverse. Kind of confusing notation because it looks like it's f to the negative first power, but that's the inverse. So an inverse graph is always supposed to be a mirror image along the identity function. So this y equals x line. If you're ever trying to graph an inverse, draw what I just did there, that blue line. And the inverse function should be doing the exact opposite as your solid curve here, as your original function. And here, I'm not going to start with that one actually. Let's start with this one over here. Here's my line. If this is really an inverse, then this is my original graph. So I should get really close to the y equals x line here, because this is really close, going diagonally. This space needs to be equal. The space of any dot I make over here needs to be equal. So we're getting further away, so I'm making my dots further away, and then they start going out of control. So let me see, how am I supposed to do that to make it an inverse? So it should look something like this. Okay. This graph is, if we were to make a guess, make a right angle, that's like 1, 2, 3, 4. That's maybe 5 units away. So we should be 1, 2, 3, 4, 5 units away on our inverse. So what I'm graphing here in dots is the inverse. Okay, like here, this is, what is that? That's negative 10 units away from my y equals x line, the identity function. So my inverse should, oh, so yeah, here's another way of looking at that. I've graphed a rough sketch of what the inverse should be, so this option's out. But here's another way of thinking about that. An inverse function has just, the only thing about it is that it's swapped the x and the y. Everything that we talk about with techniques for an inverse function, that's like tricks on finding the inverse, algebraically or graphically. But the real definition is that an inverse function has the same relation, except the x and the y have been switched. Okay? So another way of verifying an inverse is, look, this dot is at 0, 1, right? That's 0 on the x, 1 on the y. So that means my inverse function needs to have a dot on 1 on the x and 0 on the y. Oh, okay, so my graph is bad. I was like, man, that's landing right on this function. But my inverse should have a dot on 1 on the x, 0 on the y. Let's grab another point. This point, maybe right here. It looks to be almost 2 on the x, 6 on the y. So my inverse function needs to have a dot at 6 on the x, 2 on the y. So my rough sketch was a little bit off because my y equals x line was bad. Okay, maybe that's the best way to think of it. So let's just do one more point for good measure. Let's say at negative 2 on the x, we get really close to 0. It's not equal to 0, but on negative 2 on our original function, we're close to 0 on the y. That means my inverse needs to have a dot at 0 on the x, negative 2 on the y. So 0 on the x, negative 2 on the y. Our inverse function should be here. Okay? And then we said, what were the other ones? 1 and 0 for the inverse, and then this one was 2, 6, so 6, 2 should also be a dot. So this is a rough sketch of our inverse. This is definitely not it. This is the graph that has the correct inverse function. Okay? I probably should have started off with that. The x and the y's are switched in your inverse function. So find some points on this graph. Make some x and y points, like this is 2, 8 roughly. This is 0, 1. And then to graph your inverse, it just needs to be the opposite. You need to switch the x and the y. 8, 2 would be the inverse. Okay, so this is the graph that's meeting all those points.